Welcome back. Thank you for clicking on today's video. Today we're going to be continuing our talk on paired t-tests, and this is going to be one of our two options for a directional tail test, meaning a right-tailed or a left-tailed test. So we're going to start by reading the paragraph, and then I'm going to highlight to you the things that are important and we'll be using. So we had 25 students at a liberal arts college. So we had 25 students, and it was asked of these 25 students how many hours of TV and computer they watched per week. So those are going to be our two variables. We have a sample mean of 5.36 and a sample standard deviation of 15.24. And we are going to see if computer is more. So this is mostly what we're interested in. We'll be adding a few things. So computer is more is kind of a separate component. And also the mean and standard deviation and the sample size. Those are going to help us in our executing calculations. And then here at the end, it tells us the population of students and how the differences were calculated. So we're going to start with F, and that's formulate the problem. So remember here, we state our population, which is just all students. I guess I could say all college students. And then the sample would be 25 college students. And then we're stating the variables. And this is computer and TV use. And then we're going to state our parameter definition, which remember is mean difference between. And we have our two variables, so computer and TV use. I guess we could say our units, which would be in hours per week. And then it would be for our population, which is college students. And then remember when you're defining a mu sub d, it's important for you to write how differences were calculated. So here we have differences equals TV minus computer, or excuse me, computer minus TV. So you can see those things that are highlighted in yellow are really what I've used down here for my F. Now the last part of F, remember, is going to be your null and alternative. And we're always using a null of mu sub d equals 0. And then our alternative, it's dependent upon this. So this up here, computer more, and then this, the direction. Now, because we want to see if computer is more, that means that we think that this difference would be positive. So this would be a greater than, or what we called a right-tailed test. And we know that because we want this to be more, so I want this to be higher than TV, which means that this would be positive. So that's how we decide that. Remember that direction is very important. And then reviewing conditions, we actually saw this when we looked at previous videos summarizing paired data. So I would say that my conditions are met here because it's symmetric. We saw symmetric data with no outliers. So we can say that that is good, checked, and now we can move to E. So remember that in the E, we start with our test statistic, and the test statistic formula is x bar sub d over s sub d over the square root of n. So here, plugging in those values, I'm told from the problem that 5.36 is my sample mean, so that's x bar sub d. 15.24 was my standard deviation, and then we had a sample size of 25. Okay, so I'm going to plug all of that in using the 5.36 as my numerator, and then I'll put parentheses around the bottom portion or my denominator. There we go. And I come up with a test statistic of 1.76. So that's sufficient for that. So now I need degrees of freedom, which remember is n minus 1. So I have 24 degrees of freedom. And then remember to find our p-value, it's helpful for us to know what the alternative is because it tells us which direction to highlight. So here, 0 is in the center, 1.76 would be this. Because we have a right tail test, that means that I'm interested in this area to the right. And when I find that, this area is what we call our p-value. So remember to find this, you're using your calculator, second bars. You can also use the table at the back of the textbook, but this is faster for me. So remember that your lower bound is where the highlighting starts. So here, our lower bound is 1.76. And then the upper bound is where the highlighting ends, which we've talked about how that would be positive infinity, and we're equating that to 999. So do 999, and then it asks for degrees of freedom, and we said that that was 24, and that's it. So I push paste, and that gives me a p-value of 0.04, let's say 6. So the last thing to do is make our decision. Now this is fairly small, but remember when it's kind of in that cusp, like that middle area, you want to compare it to your alpha or your level of significance, which here we have 0.05. So my p-value needs to be less than or equal to alpha for me to say that it's small. So here, this is true, and so I would say that it's small. And remember, that means then that you would reject the null. So that's the end of our E. And then the D is drawing conclusions. So because we rejected the null, we're going to start by saying there is sufficient evidence. And we always restate the alternative in the D part of our Fred method. So I am going to restate our alternative. I'm just going to do it in a way that makes it easier to understand. So we're going to say there's sufficient evidence to suggest computer use is more than TV use in hours per week for college students on average. So this on average part has to deal with, so this is what we're trying to restate, and we're talking about mu sub d. So the on average deals with the mean. That's why I use that term. And then we have computer use and TV use. So that's this component. And then we have our population. So here it's for college students. So that's this component. And then the greater than 0 is really what that part is. So that is our right-tailed test, all aspects of the Fred method. In the next video, it's either the left-tailed test or the two-tailed test, but stay tuned for future videos where we do the rest of the examples. See you there.